Okay, we're going to talk about shifting, scaling, and reflecting functions. Shifting is the idea of picking up a function and moving it without changing it at all. They call this rigid because the actual shape of the function or the graph doesn't change. It's just moved to a different place. Scaling is about stretching or shrinking, so maybe lengthening or widening a function, or flattening, or something like that. And reflecting is as if you were maybe reflecting on the x-axis. It's like you put a mirror on the x-axis and you're going to flip the whole function upside down, or flip it on the y-axis, flip it left and right. Okay, so first, shifting. Shifting has to do with adding or subtracting a number. So we can add or subtract a number to the outside of a function or to the inside. If we subtract or add something to the outside of a function, it's called a vertical shift. And so if we add something to the end of a function, we'll shift it up. And if we subtract something to the end of a function, we'll shift it down. This is exactly what you would expect. You might want to pause the video here and take a screen capture or write this stuff down. The inside of the function, if we add something there, we will shift the function horizontally. Okay, so if we add something to the x value of our function, we'll shift it left, and if we subtract something, we'll shift it right. And notice that these two, left and right, are exactly the opposite of what you would expect. So for vertical, it makes sense. Okay, we're adding something going up, subtracting something going down. But if you add something to the inside, you will shift it horizontally to the left, which is backwards from what you would expect. And subtracting will go right. Okay, so for example, if we take a function, y equals x squared maybe, and we add something to the outside, that means we're just going to tack on a number after that. Okay, so x squared plus something, or x squared minus something. That's going to be a vertical shift. So x squared plus 2, that shifts it up 2 places. And if it was x squared minus 2, it would be down. The vertex of our parabola would be down here. Same exact parabola, just moved. And if we have an inside shift, that means we're actually changing the x and then squaring it. So for example, x plus 2 and then squared, okay, that would be to the left because it's plus. So that means the vertex to the left 2 places. If it was minus, x minus 2 squared, that would be to the right 2 places. Okay, scaling. Scaling can also be done to the outside or the inside. If it's done to the outside, it's also vertical. So y equals c times f of x. That's just multiplying something on the outside. That would be a vertical scaling. And so we have to see what the absolute value of the letter c is that we're multiplying by. If the absolute value is bigger than, not 0, if it's bigger than 1, it will stretch it, and if it's smaller than 1, it will shrink it, vertically speaking. Oops. Okay, and for the inside, the horizontal change, we also have to look at the absolute value of our c. And if it is bigger than 1, then it will shrink it horizontally, and if it's less than 1, it will stretch it horizontally. Okay, and this means, if you think about this, this is maybe like a decimal or a fraction. And this is opposite, again, of what you would think. Horizontal, it's backwards. It's not what you would expect. So just be very careful about that. Okay, let's look at an example of this. So if we have our same y equals x squared, if we multiply by 2 on the outside, that's a vertical stretch. It will stretch the function. Instead of being this wide, it's going to stretch it vertically longer. Okay, makes it longer. Alright, but let's look at this one right here. If we make our change to the inside, 2x and then squared. Sorry, I wrote this wrong again. The squared is supposed to be on the outside. So let me fix this. Okay, squared. So if we make the change to the inside and then square it, think about what this equals. It equals 4x squared, right? Because you distribute this exponent. And so this is the same as a vertical shift, a vertical scaling. Okay, even though originally it was a horizontal scaling. So horizontally, because this number has an absolute value bigger than 1, it will shrink it horizontally. So shrink it horizontally means that it's become narrower horizontally. Okay, but it also, this is the same function, it means that it will stretch it vertically. So stretching it vertically means to make it longer vertically, to make it narrower horizontally. So they're the same thing. They just look different. And that's why we have the opposite effect here. So it makes sense vertically, and it's the opposite of what you would expect horizontally, but it's because the two are so interrelated. Okay, great. Let's go on to reflections. An outside reflection would just tack on a negative to the front. Okay, and this is going to flip the whole graph over the x-axis. If it's on the inside, it would be a horizontal reflection. It's going to flip it over the y-axis. So this may be, again, opposite of what you would think. Vertical, you would think maybe y-axis, but just think about it this way. If it's reflecting it vertically, that means it's going to take the top and put it at the bottom. Take the bottom and put it at the top. That means it's flipping it over the horizontal axis. So you can think of it as spinning over the horizontal axis, putting the top at the bottom at the top. And the same thing for horizontal and inside reflection. It's going to flip it over the y-axis because it's taking the left and putting it at the right, and taking the right and putting it at the left. Okay, and if we do both, if we have a negative both on the outside and the inside, that's going to be the same as doing a 180-degree rotation. So let's look at an example of that. If we have y equals x cubed, it looks something like this. If we take a negative and just stick it out front, then that would be y equals negative x cubed, and that would be as if we were taking this top right here and flipping it down to the bottom, okay, moving it this way, and taking this bottom and moving it to the top. So this has been moved from here to here, and from here down to here, okay? And then let's look at if we put the negative on the inside, so negative x and then cube it. That will be as if we were moving the right to the left. Okay, so this got moved from here to here, and this got moved from here to here. And in the end, we get the same thing, and that's because y equals negative x cubed is the same thing as y equals negative x cubed. Okay, they're the same. But the reflection itself was different. Let's look at another example. Okay, so this is not a function. This is a just a triangle. It doesn't pass a vertical line test, but I think it'll help us picture what's going on. So if this is the original function, if we put the negative on the outside, it's going to take this triangle and flip it over the x-axis. Okay, so it would be an upside down triangle in the fourth quadrant. And if we put the negative inside, it would take the original and flip it, okay, over the y-axis. And if we do both, it's going to be a 180-degree rotation. Okay, so it came from here and went around and rotated down here. So first you could think of it flipping over here and then flipping down, or flipping down first and then flipping to the left. Okay, let's read this example and work it together. Given the graph below, sketch the graph of f of x equals 2x minus 3 squared plus 4. So you can tell we have a lot of things going on here. Let's talk about each of them individually. So we have this 2. What is the 2 going to do? It will stretch it vertically, or you can maybe think of it as shrinking it horizontally. Okay, and what about this minus 3? The minus 3 is going to move it to the right 3. Okay, right 3. And then plus 4. That will move it up 4. So let's start with the vertex. Okay, we have this vertex right here. We're going to move that point up 4 and right 3 to right here. Okay. And we don't have any negatives, so our graph will not be flipped in any way. It's not going to be flipped this way, or any, or rotated 180 degrees or anything like that. So it's just going to go up from there, but because it's stretched vertically, it's going to be narrower. Okay, so make sure to draw it narrower. All right, and it says to sketch a graph. So this is a keyword. On tests especially, if it says sketch a graph, that just means give your best effort. You're not going to have to plot points and make it exact. You might want to plot 1 or 2 points, but especially the vertex would be an important point to plot, but it doesn't have to be perfect. And on Math Excel, they'll give you the information you need to make it more perfect. All right, great.